Thank you. So in this talk, what I'm going to do is to revisit the speech-to-eye-lag concept, an important concept, especially for visual world eye tracking paradigms. But what I want to show you with this project is that usually some assumptions made about the speech-to-eye-lag are oversimplistic and don't generalize across different populations. So in the end, my main goal is to show you that we should rethink about the speech-to-eye-lag concept and make it more precise. But what is the speech-to-eye-lag? The speech-to-eye-lag is the time it takes us to look at the image of the word we have just heard. So in this example, it would be the time participants would take to direct their eyes to the correspondent image, in this case, the object flower. And according to different studies, this entire process takes around 200 milliseconds to be completed. And one of the reasons why this number is important is because of the way we analyze eye tracking data. And usually what we do is to define the onset of our interest period, and then we add 200 milliseconds because we want to make sure that participants had time to direct their eye movements to the correspondent image. And one of the studies that have experimentally tested the 200 milliseconds lag was the study carried out by Salverde and colleagues. And what they did in this experiment was to define the speech-to-eye lag in the absence of co-articulatory information. So participants were presented to visual displays with 4 images, and while they were seeing the images, they were also listening to auditory instructions like the ladder is the target. And the way they recorded the instructions was by recording the and the target word in separate to make sure that there was no co-articulatory information in the determiner. And the way they defined the speech-to-eye lag was by comparing the number of saccades participants launched to the target image versus to the associated distractor. And what they found was that the earliest significant time window when the number of saccades to the target image was significantly higher than to the competitor, to the associated distractor, was 200 milliseconds after the onset of the noun. And the 200 milliseconds has been used across different types of population when we analyze their data. For example, we use this lag to analyze adults' native speakers' data, but also children, both with typical or atypical development, older adults, L2 speakers, and individuals with aphasia. But the question is it reasonable to assume that the speech-to-eye lag is constant across different types of populations? Well, on the one hand, maybe yes, because some factors that might influence the speech-to-eye lag are probably similar across different populations. For example, physiological constraints. But on the other hand, maybe not, because other factors that likely influencing the speech-to-eye lag do vary across different types of populations. And we know, for instance, that lexical access speed or vocabulary size actually vary between native speakers and L2 speakers, for instance. So to address these questions, we started this project, and what we wanted to do was to revisiting the speech-to-eye lag concept by testing native speakers of English, but also L2 speakers of English, German native speakers. And the reason why we tested this group was because we wanted to see if the second group showed a delayed speech-to-eye lag or not. And in the case if we find any difference between these two groups, then we wanted to know why. And to do this, we explore the role of individual differences like age of acquisition, but also vocabulary size. Yeah. So about our visual display, we did a very similar study to the one done by Salverde and colleagues. We created visual displays with 4 images, and while participants were seeing these visual displays, they were also listening to auditory instructions. And just like Salverde and colleagues did, we wanted to know the speech-to-lag in the absence of co-articulatory information. So when we recorded our auditory instructions, what we did was to record the first part, click on the, and the target word in separate. So we were sure that there was no co-articulatory cues in the determiner. Then, following also Salverde and colleagues, the way we analyzed our data was by comparing the number of looks to the target image versus to the associated distractor. And the way we selected the associated distractor was based on the fact that both images and nouns shared a few properties, like lexical frequency, visual complexity, and also phonological neighborhood density. And finally, the other 2 objects are just distractors like there were in Salverde's study. About our groups, so we have one group, L1, and basically in this group we have 51 native speakers of English, and please notice that data collection is still ongoing. And for our L2 group, we have 79 German native speakers. And the way we analyzed our eye tracking data was by using this new statistical method based on generalized additive mixed effects models. And the way this method works is in 3 different steps. The first step, we fit a statistical game model to obtain the effects of time on the proportion of fixations to the target image. Then, from this game model, what the method does is to simulate several fixation curves. And finally, from these curves, we obtain the onset of our experimental effect. And because the method simulated different curves, we also know the uncertainty around this number, as you can see, because each curve has their own onset. And the definition of speech-to-lag using this game-based method is basically the earliest point in time at which the modeled fixation curve is significantly greater than at the onset of the time window. So in this case, at the onset of the target noun. So about our results. In this plot, what you can see is the fitted value from the game model, and on the on the x-axis, you can see the time, and on the y-axis, you can see the target fixations. And the curve represents the fitted value, and as exemplified by the second vertical dashed line, is the onset for this group that apparently is around 190 milliseconds after the onset of the noun. Then we did the exact same thing for our L2 group, and as you can see, we obtained a later speech-to-lag around 260 milliseconds after the onset of the noun. And then for sanity check, what we did was to analyze our data using the same method that Salverde did. So we compare the saccades to the target versus to the associated distractor for both groups. And as you can see here, this second method, what the speech-to-lag that gave us was 170 milliseconds for our L1 group and 260 milliseconds for our L2 group. So it seems that both methods give similar speech-to-lags for these two groups. However, something that we cannot ignore is that the saccade-based method has some limitations. For example, we know that there is a tendency for our L2 group being slower than our L1 group, but we cannot really compare in the sense we cannot say if this difference is significant or not. And we cannot also quantify the amount of inter-individual variability around this number, and because of that, we cannot also assess the role of individual predictors. So from now on, because of these limitations and because these 3 points are important for our study, I'm only going to present the results using the game-based method. And starting with the difference between the two groups, what this method told us was that this difference was around 67 milliseconds, with a tendency for our L2 group being slower than our L1 group. And despite the fact that this difference is not significant, since the confidence intervals cross zero, please keep in mind that we are still collecting data for our L1 group, so these results might change in the future. But the speech trial lag is more than a number that reflects the average performance of our samples. And with this method, what we can do is to explore the inter-individual variability by obtaining the speech trial lag for each participant. And that was basically what we did and is what you can see here. So in this plot, each dot represents the speech trial lag for each participant, and the horizontal bars represent the confidence intervals. And we obtained the speech trial lag for all participants in our L1 group and also for all the participants in our L2 group. And what you can see by comparing these two plots is that there is less individual variability in the L1 group than in our L2 group, and that in the second group, some participants behave like L1 speakers while others got longer speech trial lags. So what we wanted to know now, since we found some inter-individual variability, is what can explain this variability. So we explored the role of two possible candidates. As I said before, the age of acquisition of English, and what we found was evidence that participants who acquired English early in life showed also shorter speech trial lags. And basically, this is what you can see in this plot. So on the x-axis, there is the age of acquisition of English for each participant, and the yellow line represents the speech trial lag according to each age of acquisition. And as you can see here, participants who acquired English later in life, for instance, at the age of 10 or 12, had longer lags when compared to participants who acquired English early in life, for instance, at the age of 2 or 3. Then the second candidate that could explain the inter-individual variability was a lag scale. Lag scale is a task that allows us to measure vocabulary knowledge, and when we test L2 speakers, it also correlates with English proficiency. And for this predictor, we didn't find any evidence that participants with higher lag scale scores would also obtain shorter speech trial lags. And one reason that can explain these results is the fact that for both groups we obtain high scores, and there is also low variability in the lag scale scores. So what are our results telling us? The first thing is that the lag is not a constant number. It varies across participants, but also most important, it depends on the type of the population we are testing. If we are testing L1 or L2 speakers, we obtain different speech trial lags. And this, of course, has an impact on the way we do time window analysis in the visual world eye tracking paradigm. And because of this, it's important to think, how should we proceed? How should we analyze our data? Well, if we are analyzing L1 speakers, then the 200 millis, and if we are analyzing L1 speakers and the 200 and the speech trial lag is important for our study. For instance, we are testing prediction and we want to make sure that participants had time to look at the target image, then the 200 milliseconds might be a good estimator for our population, since that both methods gave similar speech trial lags. But please keep in mind that the speech trial lag was only tested with English native speakers, so we don't know if this can generalize to other languages or not. And what happens if we are testing a different population, and there is no information about the lag for these two groups? Well, then we have two different options. The first one is to obtain the speech trial leg for our group. And the way, by using a similar task to the one we have used or Salverde used. And the reason why we think this is reasonable to do is because this task is easy to design and also fast to run. Participants usually completed this task in 5 to 7 minutes. And I know this is weird that we are not used to do these prior tasks to our main experiment, but if you think on fMRI studies, usually they are used to run this kind of tasks to detect the brain areas that are related to the domains of language that they care for their specific task. So this is not completely untested in psycholinguistics. So this is one of the reasons why that we think that we can do this kind of task. But imagine that you don't have the time or the resources to run this task, then maybe one thing you can do is to consider the onset of your interest period, meaning that you probably should not shifting your critical time window because you want to make sure that you are not losing data for your participants. And finally, the last take-home message, what our results also showed was that the speech trial leg is not a constant value, but instead can be used as a tool to measure variables that are relevant to psycholinguistics. And in this way, you can think on the speech trial leg as a dependent variable, just like reaction times. In psycholinguistics, we are very used to use reaction times to measure the impact of variables like L2 proficiency, age of acquisition of the second language, lexical frequency. And what our results showed is that you can also do it, but now using the speech trial leg. And that's it. Thank you.
Hi, Sarah Brown-Schmidt, Vanderbilt University. That was a really interesting talk, and I thought your group effects were really compelling. I have two methodological concerns. So the first concern is the somewhat simple one, and that's when using gaze-based measures for individual differences analyses, an important prerequisite is demonstrating internal reliability of those measures. Van, who gave the talk earlier today, was giving some examples of that. So I worry quite a bit about the reliability of the eye gaze spans at a measure of a property of individuals. And so the one question is whether you looked at internal reliability of those measures. Sort of second to that, that's sort of a basic question, is a methodological concern with respect to using this eye span measure, is that in order to have a measurement of how quickly that eye can move, you need to have really dense sampling in an individual in a given task in the critical moments of interest. If your eye is at a fixation at an unrelated item at the moment when you're getting the critical acoustic information, there's going to be a delay in terms of when you can suppress that fixation and initiate a new saccade compared to if the eye is looking elsewhere. And if you're not in that sweet spot, you're going to miss the opportunity to observe saccades. We went through a big angry debate in this literature 20 years ago as to whether the eye voice span was more or less than 200 milliseconds. And part of the problem with that debate, you alluded to in the Salvador literature, is there's so few trials that are available to estimate that eye voice span that you don't really have a good measurement of what it is unless you have massive sampling. And so I worry a bit about a 5-10 minute procedure that you are not going to have nearly the amount of data density that you would need either to do individual differences analyses or to have really good estimates of what the eye voice span is in different populations.
Yeah, so starting with your second question, that's true. So when we use the saccade-based method, we lose more than 50% of the data. And this, of course, is a problem, especially if your study doesn't have enough trials per participant. And one of the reasons is because the exclusion criteria are very strict, so we need to remove lots of data points per participant. But with the GAM-based method, we don't lose that many data points, and what you can see is that both methods gave similar speech to ILEGs. But it's true that this is also a limitation of the SACAD-based method, is related to the number of trials we have to exclude based on the criteria that you mentioned.
I guess I'll clarify. The loss of trials using the Salvador's method is a problem, but I think you're falling prey to the same problem with the GAM-based methods because you don't have the opportunity to observe SACADs in that window, even if you're including those trials in the analysis.
Yeah, you are right. And about the second question about so just to be clear, the measures we used to test the individual predictors like style and age of acquisition, is that what you asked?
So following up on the lovely talk by Van earlier in the day, before you pursue an individual differences-based research program, it's essential to establish the internal reliability of the measures because the potential for a correlation between two measures of an individual is constrained by the product of their individual reliabilities. And so if the internal reliability of your gaze-based measure as a measure of an individual's performance is low, it's not possible to, just because of measurement, it's not possible to observe a correlation with another measure because that reliability is low, even if in truth there is a relationship.
It's true, yes. We didn't look at this, but it's a good point, yes. Thank you.
Hi, thank you. John Brennan, University of Michigan. I just have a question about your stimuli. This may be just a clarification. I wonder if you could say a little bit more about the properties of the onset speech segments for both the target item and the full set of distractors. And I guess the point of the question is, one way to think about the task is a which is it task. Is it going to be item A, B, C, or D? And you get the information for that at some point as the speech unfolds. I think based on this example, it's in the onset segment. So the onset segment is discriminative for these 4 items.
Exactly, yeah.
But because you're talking about these millisecond level differences, at what point, as that segment unfolds, do you get the information to discriminate between them? And isn't that the point in time where we ought to think of, it might be 30 milliseconds, it might be 70 milliseconds to discriminate, so, the vowel, for instance, or the liquid or the nasal in mushroom compared to the vowel in apron. I don't know. I wonder if you could say a little bit more about those properties of your stimuli. Thank you.
Thank you. Yeah, that's a good question. So the time it takes for us to discriminate a sound. Well, I don't have an answer to that question. We haven't thought about that, but I think it's something that we really need to look at because it's important, and especially we have different sounds, different words starting with different sounds, like plosives, fricatives, liquids, and this can have an impact But one thing is that this will have an impact on L1 and also on our L2 group. It might be different, but the stimuli is the same for these 2 groups. So
my one thought there is if the L2 speakers maybe this is a locus of individual variation, basically have a higher threshold for when they're ready to commit to, I know which segment I've heard. And that just might be an interpretation of what you're already telling us.
That's true, yeah. Thank you.
Hi, Emily Atkinson, University of Toronto. So I wanted to ask, sort of like push back maybe a little bit on this, gathering the individual groups sort of latencies here, because isn't that kind of what we're trying to see in the first place, right? So like, isn't what you're showing that the L2 speakers are processing a little bit more slowly than the L1 speakers are? And so isn't sort of a natural following from that, then all of our findings are going to be all the groups are the same because we're taking out the processing speed. So maybe that's pushing it too far, but I just feel this sort of tension here about like, if we're sort of measuring these things for individual participants, are we actually going to lose those differences that we had been finding before or hoping to find before in our experiments?
I don't think, why would we lose this information? I mean, and when we look at the participant level, we obtain like a more grained, more precise measures, right? And we see that participants behave differently. They are not all the same. So,
Right, but I guess what I'm saying is that, like, so you found that, I mean, I understand that you found that some of the L2 speakers, right, are sort of following in the L1 category. But, like, I guess to me, these findings, because it's about language and not about just like, oh, how long does it actually take to move your eye to a place or something like that, that you're kind of confounding the design of the experiment of I want this to tie this to language and a sort of speed thing, and that it essentially is going to cover what you might hope your design might cover otherwise. And there might be things over and above just your ability to hear a word and look at it, but I just wonder if we need to actually distinguish those things, or if that can be part of what we already have, and if it might not make it difficult for us to find things going forwards because it's being covered by this rather than something else that we care more about.
I see. I don't know. I would have to think if this is really a problem or not. I mean, intuitively speaking, I would say no, but I would have to think about it. Yeah.
Great.
Thank you.
Thank you.
Yeah, thank you for this. I'm Craig Chambers from the University of Toronto. I just wanted to follow up on John Brennan's point with maybe an insight coming from the old school literature where we used to use gating as a way to look at incremental recognition of spoken words. And so a longer sample is played on each successive demonstration, or starting from the very onset of the word. So you get like flower, and longer. And so we know from L2 and older adults that they actually require, even though there's, it's not time pressured in the same way as, real-time spoken word recognition is in the moment. And from those studies, we know that they actually need a bigger sample before they actually start making kind of good guesses about what the word is. And so I think that maybe resonates with that point. And also we know that individuals who are not native speakers have different buy-in to specific speech cues. So, like the onset burst, the release burst versus the initial format transitions into a stop, for example, are weighted differently in different languages. And so those would also possibly be something that would give sort of credence to that notion that there's something about your use of that, your uptake of that information and processing of it before the decision to launch the eyes is, or to shift the eyes is actually occurring.
Yeah. Yes, I agree with that. So maybe that could explain some our results, especially the difference between the two groups. Yes. I don't know, because this is the first time I'm thinking about this difference. Yeah, but I can see and I can agree with that. Yeah.
Right. Thank you.
Thank you.